Here's another type of question. Is also to identify an extraneous solution. So right off the bat, I know that the solutions can't be 5 or 3 because those are the values that would make any of those fractions 0, the denominator 0, which would be undefined, right? So the solutions cannot be 5 or 3 before we move forward. So the first step is very similar to what it's been. Multiply both sides by what the common denominator would be. So it's going to be x minus 5 times x minus 3. When you do that, you end up with these fractions, and then a lot of this can get simplified. We end up with just that left over. And then when you solve that quadratic equation, you're going to end up with 5 and -1. When we talked about at the beginning that the answer cannot be 5, right? Because 5 is a value of x that would make actually the first and the third equation equal to 0, the denominator 0. So the only solution is -1. If you were to graph this function, well, the blue is the whole thing together, and the red equations were the only place where they are crossing is at -1, right? The other place 5 is, is that vertical asymptote, so they can't cross there, right? And then the other vertical asymptote would have been 3, which is, it would have been an extraneous solution if it was a solution, but that is what that, so again, the blue is the right side of the equation, the orange was the left side of the equation, and the only place they are intersecting is at -1, which is the solution we got algebraically. So why don't you pause this, try this equation, and then come back and check your answer. So in this case, I multiplied both sides of the equation by x plus 2 times x minus 2. Once I simplified it all out, it really just ended up with x equals 2. Well, x equals 2 is a restricted value. You cannot, it is extraneous. The only solution I got was extraneous, meaning there is no solution. Okay, all right, let's take a look at example 3.